In this video, we're going to look at adding fractions with unlike denominators. So first we're going to use the diagrams to represent the problem. Then we're going to perform the operation using the symbolic representation of the algorithm. So we have 1/3 plus 1/2. Here's our unit broken into 3 equal pieces. So 1/3 is one of those 3 pieces shaded. And then we want to add 1/2. The unit is broken into 2 pieces, so 1/2 is one of those 2 pieces shaded. Now here's our issue. We want to combine these together and then figure out what part or combined amount it is of the unit. But right now these pieces are different sizes, so you could think about, say you wanted to add 2 pennies plus 3 dimes. You could say that altogether you have 5 coins, but that wouldn't tell you the value of the 2 pennies and the 3 dimes. Just like here, we could say, well, we have 2 pieces, but the pieces aren't the same size, so we can't combine them together. We need some common unit fraction, and then we'll be able to add the numerators, and our denominator will be the denominator of that unit fraction. So we could think of it as, well, 2 pennies would be 2 cents, because each penny is a cent. Each dime is 10 cents, so this would be 30 cents, and this would give us a total of 32 cents. Okay. So again, the 5 has some meaning, but it's not giving us a numeric value for the value of the coins. So that's what we need to do here. We need to break these. Notice we'll need to break them into more pieces. Okay, so the pieces will be smaller so that the pieces are the same size and we can combine them together like we did with the cents. Okay, now this is the simplest case when the denominators, they don't have any common factors. So 3 is 1 times 3, 2 is 1 times 2, they're both prime and they don't have any factors in common. So what we're going to do is, if I cut the 3 pieces each into 2 pieces, so I'm going to cut this third in half, this third in half, and this third in half. And then I'm going to cut the 2 pieces each into 3 pieces. So here's one of the 2 pieces. I'm going to cut it into 3 pieces. Imagine that these are the same size. It's very hard to draw that, but remember, theoretically, all these pieces are equal size. And now notice they're both broken into the same amount of pieces. Okay? And this will actually work in every case with any fractions with unlike denominators. You can multiply one by the other number and the second one by the first number, the denominators, and you'll always get a common denominator. We're going to see that this can sometimes be a bit tedious and make the numbers really large, and it's unnecessary. But in this case, when they have no common factors, this is what you're going to do. So I'm going to make my break my unit into 6 equal pieces. Now I'm going to combine them together. That is the 1/3. Now I have 3/6 is equivalent to the 1/2. Imagine these are fully shaded. I don't want you to have to wait and watch me fill them in really well. And notice all together we have 6 pieces, equal pieces. 5 of them are shaded, so we have 5/6. Okay. So now let's look at the idea we just used and how we can do this symbolically. So first, notice it says rewrite the given fractions with a common denominator. In this case, we actually use the least common denominator, which we'll call the LCD in the future. You can imagine why. I'm already tired writing this. Okay, and the least common denominator is the least common multiple, that's what LCM stands for, of the denominators. Okay, so our denominators were 2 and 3, and in this case we found that our least common denominator was 6. And we'll look at that a little more on the next slide. So 1/3 is equivalent to 2/6. 1/2 is equivalent to 3/6. Okay. So now we can say, well, if 1/3 is equivalent to 2/6, that's 2 copies of 1/6. 1/2 is equivalent to 3/6, which is 3 copies of 1/6. And now we want to combine them together like we did in the last picture. And combined, we have a total of 2 plus 3, or 5 copies of 1/6, which is 5/6. Okay? So that's the idea in the process of adding two fractions with unlike denominators. Okay, so let's see how we just represent this symbolically without drawing the pictures. Sometimes you can draw pictures, sometimes when the numbers are bigger you can't. It's always good to be able to visualize them. So we had 1/3 plus 1/2. First we found the least common denominator, and our denominators were 2 and 3. That's the least common multiple of the denominators. Okay. You have a few ways you can do this. The way we did this is we multiplied 2 times 3, and then we divided by their greatest common factor, which in this case was 1, because 2 and 3 don't have any factors except 1 in common. Okay, so if you can spot the greatest common factor through prime factorization, or just because the numbers are small and you can see what it is just by looking at them and using your knowledge, that's fine. Okay, we also had another method of finding the least common multiple using prime factorization, which we will look at with another problem. Okay, another way to find the least common denominator, which is fine if the numbers are small, is you can just start listing multiples. So multiples of 3 are 3, 6, 9, 12, 15. Okay, so I started with 3 and I added 3 each time. This is 3 times 2, 3 times 3, 3 times 4. I can do the same thing with 2's, 2, 4, 6, 8, 10, 12, etc. Okay. There are common multiples that we can see in these lists. Well, they both have 6 and 12. And they actually have infinitely many more. They'll have 18 and 24. Okay. But 6 is their least common multiple. Okay, so 6, if you use the least common multiple, you'll be less likely to have to simplify your result in the end. If you don't use the least common multiple, you always have to simplify. If you do, sometimes you still have to simplify, but it's not as bad. Okay, so you find your LCD. Let's go over here. Now we're going to rewrite as equivalent fractions. Using this LCD. So we had 1/3. We want to write that as something over 6. So you could think 3 times what gives me 6? That would be 2. Or you could say 6 divided by 3 equals 2, and then you know what to multiply by. Okay, so in terms of the picture we saw, what we're doing here is, remember when we had the thirds, we broke all the thirds into 2 pieces, into halves, to give us a total of 6. This represents the total ones. We had 1 shaded. It was also broken into 2 pieces because it was part of the 3. So now we have 2 shaded. Now for 1/2, we want to write this as something over 6. You could say 2 times what gives me 6, or 6 divided by 2 equals what? In either case, the answer is 3. And now we have 3/6. Okay. So now we write the equivalent fractions with the LCD, and now we're going to rewrite this problem using the equivalent fractions. So 1/3 is 2/6. 1/2 is 3/6. Now we're just going to use the process we learned before when they already have a common denominator. You add the numerators. That's the number of copies. The size of the pieces aren't changing, so it's still 6, and we have 5/6.